beautiful and harmonious and lovely. And this is a change from the schedule a little bit, because we had talk about streams today and then look at the pond and then go on the stream next week but talk about lakes, so it didn't make sense. Anyway, I digress. Okay. Lakes and reservoirs. There's Railfoot. Anyone recognize that particular shot?
I know it was close to the dock where, I'm trying to remember which one, what they specifically call it, but where they first start the tour.
It's actually like across.
It is?
Yeah, I forget exactly where, but it's their sunset cruise, and they take you out, and it's there. I think that tree might even still be there, leaning. Anyway, okay, so we had some vague definitions. Did we do this? No, we didn't do this. Remember the lentic and lotic from day one? So we're in lentic now, right? And within the lentic, we've got some vague definitions. So when we talk about lakes, those are generally bigger than other lentic systems. And then ponds are smaller. But how small you have to be a pond, or how big you have to be a lake, is not defined. So there's that. And then wetlands, they do have a particular definition in terms of like delineation for legal purposes, but in general, wetlands are shallower, and so you can have a lot of productivity and a lot of plant growth. And but they could be very vast in area, or they could be smaller in area. Mm-hmm.
Have you been to the wetlands in Murfreesboro?
No.
They have just in the middle of Murfreesboro, so like in the middle of the city, they just have this huge wetlands where they have bridges all across so that you can walk over the wetland.
Cool. I've not seen that or heard of it. Yeah.
They had like a whole
Yeah, that's cool. I think these are both from Maine, from the Acadia National Park, so a lake and then wetland there. And then reservoirs are fake, usually. Well, not always, but usually some sort of dam in a river or a stream that backs up and makes a lake-like area. But it's still connected to the river on both ends. So like Kentucky Lake and Lake Barkley, those are reservoirs formed by dams on rivers. And Tennessee, except for Reelfoot Lake, which is a weird lake, there are not any natural lakes. And we have a lot of constructed ponds. But if you go to Michigan, there's natural lakes all over the place. All right, so lake formation, to get lakes, you need to have enough precipitation and then appropriate geology to form like basins that are big enough, and the geology that won't change too much so it will hold like a big bowl of water. And this map shows in the blue dots where we find a lot of lakes. And you can see that in the kind of northern part of the northern hemisphere, we have a lot more lakes. The ice age from 10,000 years ago, where as far as glaciers went during that ice age, that's kind of a good line for where we see a lot of natural lakes, because that glacier movement scoured out the landscape and made these big bowls that where we have lakes now. So there are lakes all over the world, and there's a bunch of different types of lakes. And so we're going to talk about different types of lakes for a little bit. So the first type is a tectonic lake, or a lake that is produced by movement of the Earth's crust in some way. And some of the world's oldest and largest lakes are tectonic. And So, for example, Lake Tanganyika in Africa, 10 to 20 million years ago, that's this part of Africa. Lake Malawi, 1 to 2 million years old. Lake Baikal, 25 to 30 million years old. I think that's the oldest one. And basically their bottoms keep sinking. And so they, like lakes naturally want to kind of fill in with sediment, but their bottoms keep dropping. And so they just fill back up with water. And I know some people that were studying diatoms from Lake Baikal, and there's like species that are only found in that lake, and there's also endemic like seals and copepods and all kinds of fish and things that are only found there from that lake being so old and evolution having enough time to make all this stuff. So, and these areas of Africa, they weren't glaciated recently at all, so this is just holes in the landscape that got filled up with water. So those are tectonic lakes. So here's some examples of how the bottom can kind of fall. And there's two types that were named by some German people, so they have German names. We've got the Graben and the Horst. And Graben means grave, and I don't know what Horst means, so I don't know why it's also a name, like a man's name, so I don't know why it's called Horst. But like in the Graben, there's two faults, so the land is kind of broken at the faults, and so this whole area can sink. And so that can just kind of, tectonic activity, earthquakes, etc. That bottom can kind of keep sinking, and then water just keeps filling it in. And so you have these big lakes. And then the Horst is similar, but everything's kind of tilted. And so you tend to get the lake sort of in like this on one end of that chunk of land that's kind of dropping. So a Graben has two fault lines, and then a Horst has one fault line. And I will not ask you the difference between Graben and Horst, but I might ask you about tectonic lakes. Ruby? Okay. This is a cross section of Lake Baikal, which is just kind of interesting, but I wanted to show you this to show you the sediment part. So here we've got the current lake surface. There's some little mountainy things. And this is kilometers on this axis, kilometers. So like 5 kilometer depth. 5K, that's 3 miles. Come on people, that's deep. And look how much sediment is in this lake. And so lakes naturally just fill in with sediment that washes in from the surrounding land. And if the bottom's not dropping, a lake will eventually fill up over time, over many, many thousands of years. But since the bottom keeps dropping, it's not filling in. So, how crazy is that? It's just kind of wild. Lake Baikal is weird. Okay. This another kind of tectonic lake, so sometimes you get earthquakes that can form, create landslides where land, like a hunk of mountain falls, and if it falls into a stream valley, it can plug up that stream, and then you get water backing up behind it, and you can get a lake that way. And so this showing an earthquake from 1959 in Montana, so I think this area here is the dam that was created, and then that made the stream back up here, and you've got some trees that are now underwater. So the lake wasn't quite full at that point. So that can happen too, and that can happen rather quickly. And the this is, I want to say it's like Azerbaijan where this is. The Usoy Dam, there was a really big landslide that made this huge pile that's like 1,800 meters tall, something like that, and it created this lake, and this was in 1911. 100 years after Reelfoot was formed. 1911. And it's called the Usoy Dam because it buried the town of Usoy when the landslide happened, and so now there's this lake here. And the thing with these dammed lakes is if there's another earthquake, if that destroys the dam, you could get a big flood downstream. So they're kind of weird places. So these are kind of like natural reservoirs.
Morbid curiosity wants me to see what happens.
Yeah. It can be a pretty devastating flood.
Kind of curious if you could take like a type of device to see like the damaged
model
town.
it. Yeah,
and
you can
everything.
totally model that.
Yeah.
Well. Okay, our next type of lake is a glacial lake. And so the last ice age created lakes in places where the glaciers were present. So as the ice sheets moved back and forth, as they were forming, they scraped across the land. As they were retreating and melting, they scraped across the land. And so that would scour out bowls in the landscape, big bowls, and if those were to fill with water, then you've got yourself a lake. And this lake here, Douglas Lake, down here is where the University of Michigan Biological Station is located. And so this is a glacial lake. Pretty much all the lakes in Michigan are glacial. And it's called a kettle hole lake because there are these big, deep areas. And this particular map is showing the depth. I don't know if you can really see it where you're sitting, but there's depths here and it's in feet. So the lake kind of looks like a fish, and the right side is called Fishtail Bay, and there's South Fishtail Bay and North Fishtail Bay. In South Fishtail Bay, there's a 70-foot deep hole, and the shore drops off really fast, and it's kind of weird. And that formed because when the glaciers retreated, there was like a block of ice that was left there, and then as it melted, it just left behind that big giant hole. So there's probably was one there, one there, one there, one there, and one there. Otherwise, the rest of the lake isn't as deep. So we can have these kettle hole lakes. If you go into North Dakota, they have a bunch of pothole lakes, which are just a bunch of smaller lakes that are more seasonal, and they might dry out in the summer. They're still little lakes. So those are some glacial lakes.
Could you more or less call them vernal pools? Vernal pools? Because they come back
vernal
seasonally.
pools.
They come back seasonally.
Yeah, I think so. Maybe. Not positive, but they're similar, at least. Yeah. Some more kind of glacially, kind of mountainy, just ways that glacial movement can scrape the land, I suppose. So if you've got glaciers moving down a mountain, they can carve out spots. So here's a mountain, it's got a big layer of ice on top that moves around. As glaciers move, they push a bunch of stuff in front of them, and where the glacier stops, they leave this pile of stuff, and there's another ice block, and so imagine this all melted, and so now we've got a bunch of different type of lakes here. So there's this cirque or tarn, which is where there's a little scoop between the mountains that left a lake, where that big pile of stuff is. It's called a moraine, and that made a little bowl shape. So there's a lake there. Then that block of ice made another lake. And so here's a cirque lake, so just kind of an isolated pool, and then a moraine, and that's Douglas Lake again. It's a there's just a lot of different ones. So I'm not super concerned you remember all the individual types, but just how are glacial lakes formed.
They're so
It's a big
small.
thing. Huh?
I said those are so small.
Yeah, some can be small and some can be really big. Like the Great Lakes are also glacial. So, yeah, depends. And then, just for Gruba, he likes the Paternoster Lakes, which is where you've got like these little scoops that go down a mountain range, and you get these little circular lakes that just keep popping up as you go down a mountain valley. And that's the Paternoster is referring to the rosary beads, so beads on a string. So these lakes kind of look like beads on a string. And then the streams connect all of them, so that's the string. Didn't know there were so many lakes, did you? We're not even done yet. Right. Moving on. So, volcanoes can make lakes. So when a volcano blows the top off of a mountain, if blows the top off, and then you're left with a depression. If there's like a bottom to that depression, not just more lava, but you get actual ground underneath it, and that fills with water, then you can get a volcanic lake. If you've heard of Crater Lake in Oregon, that is a volcanic lake. These are often really nice, like deep and clean and low productivity, like really nice because there's not a lot of runoff because there's not a lot of land that slopes toward the lake. So most of the land around the lake is sloping away from it, so you don't get a lot of junk washing in there. So those are usually pretty nice lakes. Also known as caldera or mar lakes. Yeah, so there's that, and then ones that we might actually see around here. There are some lakes that are connected in some way, or there's some historical connection to a river. And so oxbow lakes are from a little outside loop of a river that got isolated. And rivers actually move around a lot, and I don't mean just how they flow. They change, like they move their channel. If rivers are allowed to do what they want to do naturally, their channels would change over time. And I don't have this in your slide, but I wanted to show you this. It's a map of the Mississippi River, and the clear is where it is now. I think it's the clear is where it is now, and all of these other ribbons are where the Mississippi River used to be in the past. So even a river that big would change course and jump out of its channel and change its meanders, because as it moves around like this, like if you get a big flood, that can, like as you're going around a bend, that can like bust out that bend, and then you're going off somewhere else, so it can change course.
What's the difference between a fluvial and an oxbow lake?
So an oxbow is a type of fluvial lake. So fluvial just means it's connected in some way to or historically related to a river somehow. And then oxbow is a fluvial lake. So the point of this slide is just to show you that rivers, historically, they change course. So this oxbow thing, so this used to be like, it looked like, look at this picture, that the river was down here and then probably went around that way. And then there may have been this, some kind of event that just removed that oxbow from the main channel, but that channel is still there and still has water in it. They're also known as billabongs in Australia. And then you get to say billabong, because that's fun. Okay. And then finally, reservoirs form upstream of a dammed stream or river. And so they can be natural, like the earthquake, landslide ones, but in general, most of them are from dams that we build and put there on purpose to build a reservoir. And they're described as dendritic, so lots of little branches, because they're basically stream valleys or river valleys that have been flooded. So if you just imagine what a stream looks like on a map, and then just make it wider and taller, and that's your reservoir. So like Barkley, Kentucky Lake here, I always forget which one is which, but you can see the little arms that are all coming out. It's all long and skinny, and that's just basically an exaggeration of that river channel. So that's what dendritic means. It's kind of like a network, like Quibi. And they tend to fill up with sediment over time, because rivers and streams move a lot of sediment just normally. And if you put a dam there, all that sediment gets backed up. And the Colorado River that feeds the Grand Canyon, they actually had a sediment release because they were starting to lose sandbars and stuff in the Colorado River in the canyon, where people wanted to go rafting and camping, but the sandbars were where they would camp, and those were disappearing, and so they released a bunch of sediment to try to recreate those a little bit. Reservoirs often have managed water levels, so with the dam you can keep water back or let it out if you want to, for whatever reason. And so the streams that feed the reservoir may have different characteristics than what exits the other side of the dam, what the water's like when it leaves. And so that depends on where the water comes out of the dam. If it comes out of toward the top of the dam, you can have warmer water that leaves the dam. If water comes out of the bottom of the dam, you can have colder water coming out. And this is Buford Dam in Georgia, which is the dam that creates Lake Lanier, which is the water supply for Atlanta. And you can see down here the water is coming out of the bottom of the dam. And so this water is pretty cold, and they actually have, they stock it with trout, and you can go trout fishing in there, and trout don't like warm water, they die in warm weather, so that's kind of not natural. And also the thing I said about the sediment, you may not have the normal amount of sediment coming through. And this is just to show you the water temperature coming out of the bottom of that dam in August, in late August. We'll just use Fahrenheit, 52, 53, 54, 55 degrees. Do you think water would normally be that temperature in Georgia in August? No, you could not go into a normal stream or river in August in Georgia and have 50-degree water. That would not happen. So it's quite a bit colder than you would normally get in a whole stream down there. Okay, so those are our types of lakes. We're done with that part now. And so Pacer Pond is a little tiny reservoir, and will be where we are on the dock, the walking path that's right next to it, that's actually on the dam that forms that pond, which is just basically like a retention pond. Just runoff feeds it, not a stream. All right, here's some habitats that we talk about in lakes. So things on the bottom, that's referred to as the benthic zone. There's a scientific society, the Society for Freshwater Science, it used to be called the North American Benthological Society for the benthic zone, except no one knows what benthological means, so we decided to change the name to the Society for Freshwater Science, so like regular people know what that means. And the algae that I study, I prefer to study the benthic algae, the stuff that grows attached to the bottom. A lot of the macroinvertebrates that we'll look at, most of them live in the benthic zone also. And so that's a term that we use a lot. Another term we use a lot is the littoral zone or the littoral zone. I learned it littoral. Grubau might say littoral, and maybe Blanchard, I can't remember, but I can't not say littoral. That's just how I learned it. So, but that's the area that's like right on the shore, and it's the benthic part. Well, it's really the whole, like all of the water and the what's on the bottom at some distance from shore up to like a certain depth. So as long as you've got plants growing, that's considered the littoral zone. There's still enough light reaching the bottom that you can get plants growing and algae growing on the bottom. So that's a term we use. And these others, oops, hello, wrong button. Oopsie. These other terms I don't see them used very much. Might talk about the photic zone, just where light penetrates and photosynthesis can happen. Might talk about that. The pelagic zone is basically where water gets deeper. The linetic zone, once you're past the littoral zone, once water is deep enough and light's not penetrating deeply enough to get algae growing on the bottom. But the linetic zone is like the open water, but there's enough light for stuff to photosynthesize, is the linetic zone. And then you've got this profundal zone, which I don't use very much either, and that's it's dark there, and so you don't get much in the way of photosynthesizers. And where you find photosynthesizers, you often find the things that eat them and the things that eat photosynthesizers. All right, groovy. Okay, so the fun thing that we'll talk about is turnover and stratification in lakes. So this big bowl of water that is a lake doesn't just sit there and not move at all. There's actually some rotation of the water that happens seasonally. And this, the reason that there's turnover or mixing of water has to do with water temperature. So remembering back to your properties of water, what temperature has the water that's the most dense?
Cold.
4 degrees Celsius.
4 degrees Celsius, yes. So 4 degrees is the densest water, and then it gets less and less dense as you get warmer. And then as you get colder, it starts to form ice, and so it becomes way less dense. So, so cold water tends to sink, and warm water tends to be on top of cold water, right? So that's just a density thing. And if water in an entire lake is all the same temperature, then wind is able to blow across the top and get it moving and start a rotation. So water that's isothermal, so isothermal is just a fancy way to say all the same temperature. If water's isothermal, it can get mixed up. In the winter in the winter where there's ice cover And in the summer, and I'm gonna show you pictures of this. There's the phenomenon called stratification. And this is where water of different temperature will form these layers. And we put names on these layers. And so we might look to see if we have these layers in Pacer Pond today. And so the top layer is always called the epilimnion. Epi means like upon.
So it's like the epithelial, but that's
Yeah,
the
like, yep. It's epilimnion. And so that's the top layer. And then the bottom layer is called the hypolimnion. So hypo means below. So that's where that comes from. And then in between the epilimnion and the hypolimnion, you've got the thermocline. So warm water is going to be on top of cold water, right? And as you transition from warm to cold water, there's a change in temperature. And it often happens really quickly in a short distance, and that's what the thermocline is. So you'll have like warm water, and then rapid change, and then your colder water underneath it. So this, I'll show you the diagrams. Yeah. So if we look at this particular lake, so here's a nice lake, and this is the summertime. It's gotten pretty warm, and so we have this top layer that's really warm, a bottom layer that's still pretty cool, and then an area of rapid temperature change in between. So that's that stratification. And there's a pretty large temperature change. We've got 22 degrees Celsius up here, and then all the way down to 4 degrees. So that's a pretty wide change. When you look at, you can see the similar thing in the wintertime, but the temperature change is a lot smaller. So with ice cover, you tend to have a little bit warmer top layer, and then the colder bottom layer, but still the top, well, actually the top layer is colder because it's next to the ice, so that's kind of weird. And then this bottom layer of hypolimnion, and then a little bit of change in between. So winter is weird because the ice kind of messes with what we just said about temperature with the warmer being on top. But going back, so that was our slide there. And so what a thermocline would look like, so if you were to measure temperature every meter or so and plot that on a graph. So in lakes, we like to have these upside down graphs, because like up here is the top of the lake, and then going down, we're getting deeper in the lake, so that just makes more sense to look at it that way. You measure temperature every meter, in the epilimnion, it might stay pretty much the same, but then you get this rapid decline, and then the hypolimnion is much cooler. So, so down here it's at about 8, so not as cold as 4, but that particular example it's at 8. Alright, does that make sense so far? Okay. So what happens? Alright, so we are in summertime right now, and we'll talk about how this sets up in a little bit. But just take for granted that we've got this warm layer on top, the thermocline, and the hypolimnion on the bottom. So we have the epilimnion. And water can circulate like just within the epilimnion. So as water or as air blows across the surface, that can get water moving, and you could get like a little bit of circulation, but just in that top layer. And so the thermocline and the hypolimnion are just kind of sitting there. Then fall comes and it gets cooler, and so as it gets cooler, that water cools down and it keeps cooling down, and as it cools, it sinks, so a little bit of warmer water will come to the top and get cooled off, and you keep cooling things off, and eventually, once you get closer to winter time, all of the water will be 4 degrees. And so once all of the water that was on the top matches the temperature on the bottom, then you can get turnover or full mixing of the lake. And so this is like an event, and you can even see it sometimes. Like you can see the water is like, now it's all brown because it's completely mixing and you're bringing up sediment from the bottom. And so this is kind of an event that happens in the fall. And this can bring nutrients that were stored in the sediment, it can bring those up into the water, and so once summertime comes next year, they'll have more nutrients to use. So this is like an event that happens for a lake. And if there's no ice cover, that will keep happening all winter until we get to spring. And then once it starts to warm up, once we get like days without a lot of wind and it's nice and sunny, once you start to warm up that top layer, it doesn't take a whole lot of temperature difference to make a layer that's not going to mix with the colder water. So then we start that all over again. In places where you get ice cover, so you've got the 4-degree water, and then it gets really cold and you've got ice cover. So remember, the 2-degree water is lighter, or not lighter, it's less dense. And so that can rise to the surface, and ice will keep it at around, the ice is 0 degrees, even if it's colder on top in the air. But underneath, it'll be, where there's water, it will be around 2. But the bottom, since it's the most dense, it'll be 4 degrees. And then a tiny little thermocline in between. But if there's ice cover, there's definitely no rotation happening at all. Alright, does that make sense? Could you explain that process on the test? Yes.
So for the winter, I noticed that it's actually the coldest up on the top and it's the warmest on the bottom in versus summer. Is that because of the heat the earth gives off?
So remember that water is most dense at 4 degrees, so that's going to be on the bottom. And so in this case, it was warmer water that was less dense. In this case, it's colder water that's less dense.
Okay,
So that's
gotcha.
floating. Yeah, that kind of messed me up earlier too, actually. Okay, anything else? So lakes can be described by their turnover patterns, and we have what we call dimictic, which means they turn over twice in a year. And we go back to this real quick. So the spring turnover is 1, the fall turnover is 2, so that's dimictic. So these are lakes that are probably going to have ice cover in the wintertime.
So like our lakes, they don't usually get ice cover.
Right,
So
yeah.
they just have one.
Yeah, so, and we would call that monomictic. Yeah. Yeah, we get, ice cover on Pacer Pond for like a week, maybe, when we get those evil ice storms.
Is that enough to stop the turnover?
I mean, it could be enough to create a little thermocline in there, but we don't always get ice cover. But it can't just be like a little bit of ice on the edges, it has to cover the whole thing.
Is there a term if it's like, if a lake is not always, but it's usually monomictic?
I don't know of one.
Because it can be colder.
Yeah, like from year to year, like one year we could be dimictic.
Or
Yeah, I
just,
think it's just
to be
the
like, this year
general-
it is.
Yeah, it's, like we would describe a lake as, like, it's usually monomictic, but every 10 years on average it's dimictic. So might be something we would say. Just to be confusing, there's polymictic, and this would be a lot of turnover in a year. This is more common in tropical places where the water doesn't get down to 4 degrees, but the warmer water is, the more easily it will form layers. So you can get like a hypolimnion that's actually pretty warm, but it's still colder than the water above it. But then you might have a cloudy days for a few days, and that might cool off the top layer enough that you could get the whole thing mixing. So that's more tropical and kind of weird. And then just to be like thoroughly confusing, you can get stratification in lakes that are like fjords. Fjords, like to say fjord, it's going to say fjord, that are connected to the ocean. So there's a layer of fresh water on top, and then there can be high salinity salt water underneath, and that high salinity salt water is more dense, and so that is going to hang out underneath the fresh water. And so that can set up a stratification in a lake. And I remember a long time ago seeing a nature show about a lake somewhere in the tropics that had some kind of weird saltwater spring coming into the lake, and it was just always there, and so there was this like hard like separation between that freshwater layer and the saltwater layer.
I think one of the strangest things I've seen was, I'm trying to think of if it was what show it was on, but it was like in the middle of the ocean, and the bottom of it there's like a lake.
Yeah.
And there was like a water separation between
Where it's like
the
a
ocean.
pocket of super ocean.
Yeah.
Oh,
Because
wow.
like salinity.
Yeah. Yeah.
It was
Yeah,
really weird.
That's super weird.
And you would see the recording of the fish kind of just sitting on the embankment, not really going in and out of it.
Probably too much
Wow.
salinity for
Yeah.
it.
Yeah. Salty. And just some other random things about lakes that are kind of interesting. So, the mixing leads us to just like how air and water sort of interact physically with each other. And so thinking about waves forming in lakes, and if there's something called a longer fetch that gives you bigger waves. So what that means, so lakes have all kinds of weird shapes. They're not round circles all the time. And so this lake is kind of longer than it is wide. And if the wind direction is coming from like the bottom to the top, that wind has a lot of space really to kind of like get that water going. And so by the time you get to the other side of the lake, there's probably some like pretty big waves on that side of the lake. If the wind's going from right to left instead, so that's the fetch, the length of the lake that's perpendicular to the wind.
So basically longer stretch instead of fetch, bigger waves.
That's a way to remember it. Yeah. They call it fetch though.
Keep
But I like
fetching
stretch.
way.
And so this lake has a shorter, or with the wind going from right to left, the fetch is shorter, so the waves won't get as big just because there's just not enough room to build up speed. And there's even a little mathematical curve about it, so almost linear but not quite. As the fetch lengthens, this is in kilometers even, the wave height can increase. So like in the Great Lakes around Michigan, the big lakes you can get some really big waves, and the smaller lakes you're never going to get a very big wave. Alright, I want to talk about a sesh. That's a weird word. Sesh, like creme fraiche. And this is when the entire surface of a lake kind of rocks. So imagine if you were like walking and carrying a bowl of water, and then you suddenly stop and think about how the surface of that bowl would do that. You know what I mean? Know what I mean? So that lakes can do that, and it's usually wind. I mean, it's going to be a wind-caused deal, and so that's basically if the wind is blowing across the lake for a long time, that can like kind of push a bunch of water toward, like if the wind's blowing in the same direction for a long time, it can kind of push a bunch of water to one side and basically taking it from the other side. It could be an earthquake too that causes, like when you're walking and you stop, you imagine that your stopping action is kind of an earthquake that could cause a rocking of the lake surface. And it won't be like as fast as in a bowl, it'll take longer. It can last hours or it can last days. And these two pictures are from Lake Erie. And so Lake Erie is kind of shaped like this. And so the wind just going straight across it, so that's a pretty long fetch. And this end, that picture on top is from this end of the lake where the wind was starting. And its water is gone because it's being blown to the other side of the lake, which looks like this.
So it's a kind of visually like tides. Where it's
Kind of
like,
just in a smaller amount of space. And if you were able to like take a cross section of the lake, the surface would look like that.
it's like if you tilted a bowl, kind of.
Kind of, yeah.
Where the water's gonna be like that.
Yeah, yeah. So that can be kind of weird. So, so around Lake Erie, if there may be a sesh, and that would be on the weather report. There can be an internal sesh where the hypolimnion rocks instead of the surface of the lake. Or the thermocline rocks. Yeah. And I think I experienced that one time when I was in Lake Superior, because that lake's normally kind of cold, but and so like if you go wading around or swimming around, you can't last very long. But the day I was there, it was like the water was super warm, and I think the wind was just blowing warm water to that shore, and so I think the hypolimnion was rocking. So you don't see it on the surface, but you can get a weird temperature thing going on. Alright, groovy. And there's a diagram showing you that. So, and this is the hypolimnion part.
Kind of reminds me when you're making a bowl of cereal and then you got the cereal that overflows and you're trying not to rock it too much, so it just spills to the side.
Yes. This is the last thing. Langmuir cells, I cannot explain why they show up. I don't get it, but you can see them, and it's kind of cool. So I'll show you a picture here. You see these like little foam trails that are all parallel to each other. And I saw this once at Reelfoot Lake. I was like, oh, it's Langmuir cells. And what's going on is, like, where it's foamy, you've got, like, here would be the foam. There's water rotation that's, like, making tubes of, like, cylinders of circulating water. And so as you've got two that are coming, like, at each other, and that makes those foamy trails. And then the other two next to each other go the opposite direction, and then the next ones go toward each other. I don't understand the physics, it's too hard for my little brain. But someone does, it's not me. It has to do with the waves and the wind, and I don't know, but you can see it when it happens. And it's not super common. It's kind of another diagram that's similar concept but different, same concept, different idea. So they're like parallel to shore, and like the wind's going that way and waves, and I can't.
So is it like a mixture between like the wind and the internal lake currents that's causing it?
I don't know. That could be. Yeah, because it's something with the wind being parallel to shore and